No one? You heard about this creature? Kirobo is a small robot, 34 centimeter, comes to about your knee or something, built by Japan. Needless to say, it's Japan is ways ahead of the rest of the world in robotics, and this robot has been sent to space on Sunday. That is how it came into the news. If you are watching some news channel, well, maybe BBC or something else, the Japanese Space Agency has sent this robot into space. It is a small robot which can recognize speech, understand what you are saying, talk back and recognize faces and so on essentially. And the idea is that this robot will be a companion for a Japanese astronaut who is likely to who is scheduled to go in November sometime, and that is an interesting idea, robots as companions of people. So, if you remember, we had talked about, or I had mentioned about this chess grandmaster David Levy. In 1968, he had a chess bet. Okay, so we had talked about it in the last class, and he had said that no program can beat him for the next 10 years, which he luckily survived the bet, because now as we know chess playing programs are much better. But in 2008, he is talking about robot companions. So, he has swung from one end of the pendulum, in which he believed that a computer program could not do anything interesting, to the other end where he believes that robots can be companions to human beings essentially. Okay. So, he wrote this book, it's called, it was published in 2008, and the title of the book is Love and Sex with Robots. And the idea behind the book is something which many parts of the world are looking at, especially those parts of the world which have aging populations, where they do not have enough young to take care of the old. But of course, he is not talking of the old here, but where robots could take care of people essentially. So, robots can be companions and so on. Okay, so, that is a book he wrote in 2008, and for example, what looks like a young lady, whereas in fact it is a robot, the thing here. So, this idea of creating robots in the image of us has been around for a long time, and we will look at some of this history today, and robotic companions could well be there in the future essentially. Okay. So, we saw in the last class, so I will just quickly go over this. We saw the syllabus which will be available in some place, and the textbooks, and these are the two books that we will be following in the next couple of lectures. AI, the Very Idea by Hogeland, and Machines Who Think by Pamela McCorduck. We saw some definitions of AI. So, there are four things here. One is that if they do, machines are intelligent if they do things which human beings are considered to be intelligent for. Another definition is that AI is the enterprise of solving hard problems and finding polynomial time solutions, and we must of course qualify that by saying that these are approximate solutions, or not, they are not necessarily optimal solutions. And then the AI is the study of mental faculties by creating computational models. That is the idea given by Charniak and McDermott. But the definition that we like most is given by Hogeland, and the definition says that AI is interested in the idea of machines with minds of their own essentially, and this is the idea that we will pursue in the next couple of lectures essentially. We asked some fundamental questions in the last class, what is intelligence, what is thinking, and we got several responses here about what we think is intelligent behavior. So, problem solving, reasoning, learning, perception and language. Language was mentioned in the last class at all. So, let me ask a question here. Language is something which is unique to human beings, and many people believe that it is instrumental in intelligent behavior. But the question that I want to ask is, if you look at language and thought, what came first? So, was thinking a precursor to language, or was language a precursor to thinking? In a sense, is our ability to think dependent upon the skill of language that we have, or did language come because we are able to think? So, let me see what people think here, and again I will emphasize that there is no correct answer to this question, in the sense that it is like the chicken and egg problem. But what do students think? And I hope students from Mandi will also join in with their opinions. Can we think without language? Okay, let me ask it this way, or is thinking closely tied to language? You are saying no, we can think without language. So, can you sort of justify or support your answer?
Images don't necessarily have a language.
Sorry?
Abstract
Graphical images or something.
Graphical images don't necessarily have a language.
abstract thoughts we have, so those are not language, those are not language dependent or something.
Yeah. So, abstract thoughts are not language dependent. Now, that is a somewhat debatable claim essentially. So, the question I am asking really is that are thoughts made up of language, or are thoughts, do thoughts imply language? Can we think without taking recourse to language? Okay. So, when we say language, we really mean symbol, because language is just one kind of a symbol system essentially. Is it possible to think? Now, you said graphics or visual images, yeah, that is a thing which comes to mind, that if you recall visual images, then you are not really talking about words or things like that. Interestingly, you have heard of Chomsky, right? Yeah, so is there anyone who has not heard of Noam Chomsky? What is he doing nowadays? He visited India a few years ago as well, essentially. So, he has actually become a political activist. But many years ago, when he was active in linguistics, he put forward the idea of universal grammar. Okay, so, UG as it is called, and he said that human beings are born with a grammar in their heads, whatever that means. Okay, in their heads, we will not explore that question, but essentially our brains come pre-wired with the faculty of linguistic ability, which is sort of some kind of a grammar. And what he says is that depending upon which place, which society you grew up in, you tune that grammar to that particular language that exists in that society essentially. Okay. So, Chomsky of course, is saying that language came first, that we are born with the ability to use language, and maybe that helped us, because he is not saying that, but maybe that helped us in our ability to think essentially. But anyway, that is an open question, maybe at some later point we will come back to it. So, we also asked some questions as to what is a machine, is a computer a machine, and we said that yes, we will assume that whenever we talk of machines thinking, we will be talking about computer programs running. And of course, we asked the question that are we machines, that is something you can ponder over and some reactions to that. Okay, so, historically there have been arguments against thinking. So, we had discussed 3 arguments by Dreyfus, which say that there is something intuitionistic going on in our heads, something which is kind of intuition which we cannot define in terms of rules. So, when Dreyfus was talking about all this, people were talking about rules as a mechanism for reasoning, and he said that there is certain kind of unconscious instincts that we have which cannot be captured in rules essentially. John Searle, a philosopher, used the Chinese room argument, and the essence of the argument was that just because you can manipulate symbols and convince somebody that you are doing something, like for example, children doing long division, do they understand whether what is real, what are they really doing, or when even younger children do addition. So, they add 2 numbers by looking up a table, do a carry over, then add, and so on and so forth. You are doing simple manipulation. Are you understanding what is behind that activity essentially? Or older students, should I say, when they are dealing with things like Fourier transforms and so on and so forth. Are you doing it mechanically, or have you mugged up a formula of how to integrate something, or do you understand what is happening behind that essentially? So, what Searle says is that symbol manipulation, the ability to manipulate symbols is not necessarily a guarantee that you are intelligent. Maybe you are following some rules which somebody has taught you, this is how you add numbers and so on and so forth. And Penrose, the celebrated scientist, Nobel laureate, says that there is something quantum mechanical going on in our brains essentially. So, there are other arguments based on emotion, intuition, consciousness, ethics and so on, which we will ignore. Then along came Turing, Alan Turing, and he said that the question whether machines can think is meaningless. Let us not try and answer, because first you have to answer what is thinking, and only then you can say whether machines can think essentially or not essentially. He said that let me prescribe a test which is called as the imitation game, and which we now call the Turing test, and at that time when he prescribed it, in this book that is mentioned in this slide here, in the paper that is mentioned here, Computing Machinery and Intelligence, appeared in 1950, it is available on the link that is given in the page. He believed that in 50 years from then, which is in 2000, machines would be able to pass his so called Turing test essentially. And what is the test? This is where we stopped in the last class. The test is that there is a human judge sitting out there interacting over some medium. It could be nowadays a mobile phone where you are chatting with someone, or in those days it was a teletype which was connected to another room in which the other person was responding. And what Turing said was that if the human judge can confidently discriminate whether the other side is man or a computer, then the computer has failed the test. But if the computer can most of the times convince the judge that the judge is talking to a human, then the computer has passed the Turing test. So, this is what is known as a Turing test of intelligence, you might say. To test whether a system is intelligent, you pass it through the Turing test, and then decide whether it is intelligent. You do not ask what do you mean by thinking, what is intelligence, and that do not go into fundamentals. And as we said, there is a Loebner prize which is currently available, still not $100,000 US for anybody who can pass the test, so to speak, essentially. So, the question which I left the class with was, what do you think of the Turing test as a test of intelligence? Do you have any views on this? Is it a good test? Is it a bad test? Do you agree that if a computer passes the test, it will be considered to be intelligent, it will qualify to be called intelligent? Any thoughts on this? Okay, while you are thinking, meanwhile, let me address the Monday students. So, welcome again, and the basic idea of the first few lectures is that they are going to be a study of history and philosophy behind AI, what has happened in the last few 100 years, which has led to the development of AI currently. And after those 2 or 3 lectures, we will have a qualitative shift, and we will spend most of the time using algorithms, using the syllabus which I will convey to you essentially. So, is it a good test or a bad test? Surely you can have some opinion.
I mean, I cannot judge the intelligence because like any programmer can see the past behavior, like what type of questions are there in the conversation, and based on that data.
Yes. In fact, that is precisely what happens. This Loebner prize is a contest which takes place every year, and as we said, this year it is going to, the final is going to take place on September 14, and this one of the leading programs is called IZAR, and this is a conversation transcript from the earlier competition round. So, you have seen it and you can look at it again. So, obviously, people who write such programs look at the history, just like students who write exams, they look at the history of past questions, even such people this thing. So, that is all allowed, everything is allowed. Can you write a computer program which will fool the judge, if you want to use the term, to thinking that the judge is talking to a human being? And this was the conversation that we saw this IZAR had, and he is making statements like I am getting into, when he is talking about music, he is making statements about, in the last couple of lines you will see I am getting into Humi, a type of Mongolian throat singing, what kind of music do you like? So, obviously, such a program will have to be equipped with general knowledge, at least which everybody knows essentially. Okay. So, I mean no human would not knowing it essentially. So, you have to have that kind of a knowledge. Of course, you also have to have some kind of a rhetorical skills and ways of getting around questions and things like that, all that is part of it. What if I were to give it 2 12 digit numbers to multiply, say what is the product of 2,029,000,000 whatever, some 12 13 digit number, I say I give 2 12 digit numbers and ask it what is the product of that, and the computer, poor thing, being a computer, gives me the answer before I even finish the question, almost finish the question. Won't I be able to say no, you are not a human being? Okay. So, I will again leave it to you to think about this. Is this a good test or a bad test? But we did mention ELIZA or ELIZA, program written in 1966, when computers had just come into place by Joseph Weizenbaum, and it is a program for simple manipulation of rules. It would take the user's input, do a little bit of twisting, turn it around a bit and put it back to the user, and to some people it's one version of it called doctor sounded like a psychotherapist, and they would start talking to the program as if they were talking to a therapist. And this was a Russian scientist who was visiting Stanford, who actually went through this conversation, and we saw that in the last class. And what you see in purple is the fact that how this program is manipulating your input into generating its own output essentially. So, something like I am feeling a bit tired, and it says why do you think you are feeling a bit tired. This is standard, and new questions like tell me about your family and so on. Weizenbaum did not like the way people responded to ELIZA. It is a very simple program, it is nothing deep sophisticated about it, but people used to interact with it as if they were interacting with somebody who understood the complexities of their problems and things like that essentially. So, he wrote this book Computer Power and Human Reason from Judgment to Calculation. He wanted to say in essence that AI is not possible, that computers can never be as deep thinkers as a therapist can be essentially. So, there is a difference between what can be and what appears to be essentially, and human beings have a tendency, we are willing to suspend our disbelief essentially. We are willing to watch a James Bond movie and believe that all that is happening is possible, and all kinds of things essentially. So, the fact that a man made artifact could respond to human input easily leads humans to take a leap of faith and conclude that it responds intelligently and knowledgeably. Throughout centuries we have been doing that essentially. So, in olden times in Egypt, people believed that statues which moved and gestured had a sort of a soul, and they could represent a god or a dead person and communicate through a priest essentially. So, I said olden times Egypt, but even today you can find in our country this sort of a thing happening. You have people who read tea leaves, or people who communicate with your ancestors, or people who go and get their fortunes foretold by a parrot who pulls a card out of a bunch of cards. So, we do it all the time, and we believe, well not everybody, but we mostly believe that this is possible essentially. Such practices continue to this day essentially. And in Europe there was a great fascination for such moving figures, moving automata or statues which could move around and shake their heads and so on. So, Pamela McCorduck writes in her book Machines Who Think that in medieval times the art of making clocks, decorated and animate figures were very popular essentially. So, if you go to Germany you can still find them, for example, in clock towers, when it is 12 noon, suddenly there is a lot of music and some statues come out and do something and go back in, that kind of stuff. So, it was popular in medieval times that learned men kept robots essentially. Okay. By learned men, society was not very as egalitarian as it was now. There were the kings and there were the peasants and there were the learned men and there were the traders and the warriors. So, there were classes of people. The learned men kept robots, and most interestingly to most people there could be little difference between a human figure that nodded, bowed, marched or struck a gong at a precise and predictable moment, which is entirely feasible. You can construct machinery which is accurate, and we know that such machinery exists. So, between such machinery and a human figure that answered naughty questions and foretold the future. So, for us there is no difference. If we can construct a statue which can nod its head and we ask a question and it nods its head, we are willing to say that yes, it understands what I am saying and it is telling my future, and that sort of a thing. So, in the study of history that we are going to be doing, there are going to be two strands. One is this mechanical side of talking statues, moving statues and things like that, and the other is going to be the philosophical side, which is about what is the notion of the mind, how did the notion of the mind come, so those questions will come to a little bit later. Let us first address the mechanical side of things essentially. So, all this is happening in Europe. We have this notion of artificial people. In Homer's Iliad, Hephaestus is supposed to have created this Talos, a man of bronze, which would patrol the beaches of Crete. Hephaestus is also supposed to have created Pandora. You might have heard about Pandora, who commissioned by Zeus. So, Zeus was a god to punish mankind for accepting Prometheus' gifts of fire, and Pandora is supposed to take that casket, but she is so curious about it that she opens the casket essentially, and lets loose the evils into this world essentially. Pygmalion. Remember this Bernard Shaw's play called Pygmalion, in which there was a character called Eliza, which was the name of the program written by Weizenbaum. Pygmalion also was a mythical creature who was disappointed by real women and created Galatea in ivory, and Aphrodite, who was another god. So, the Greeks also had many gods, like we Indians have, gods for doing different kinds of things. Obliges him by breathing life into Galatea, and apparently he fell in love with his own creation, like in the play. Then Daedalus, you must have heard about, more well known for his artificial wings. He wanted to fly, but he was also credited with creating lifelike statues that wheezed and blinked and scuttled about, impressing everyone. So, this is a important thing, the statues which could seem to be autonomous, and if you are autonomous, you must be intelligent essentially. So, that is a leap of faith that we are making essentially. Then about 1000 years ago, Pope Sylvester is said to have made a statue with a talking head with a limited vocabulary and a penchant for predicting the future. So, that is why people are willing to believe that this talking head can tell you your future, and on being asked a query, it would reply yes or no by shaking its head essentially. But all that is in myth essentially. There is some more mythology. Paracelsus, who was a physician who lived from 1493 to 1541, is supposed to have created a little man called Homunculus essentially. Okay. And he made this statement: we shall be like gods, we shall duplicate God's greatest miracle, the creation of man essentially. Because in Western thought, we have been created in the image of God himself essentially, and so we can be like him and create creatures in our own image, so to speak. So, he lived in Switzerland, and Rabbi Judah Loewen is supported to have sculpted a living man from clay, and he called it Golem, to defend the Jews of Prague. So, in Jewish folklore, a golem is an animated anthropomorphic creature made out of inanimate matter. So, that is a kind of a image, the kind of creature he is supposed to have created essentially. All this material that is available in Wikipedia, and I have given all the references from where I have taken the images. So, let us talk about real mechanisms. Some of them are mythical. Of course, we cannot imagine a man made of clay which could do all these sort of things, but in parallel real machinery was being created essentially. Some of these ideas came from the east via the Arabian countries, and in 802 Harun al Rashid, we heard his name in other contexts as well, is said to have presented the Emperor Charlemagne with an elaborate clock which sent out dozens of cavaliers from a dozen windows each and back again. So, this is a kind of clockwork which, if you go to Europe, you can still see now essentially in the town hall or city center, we have this sort of machinery still operating. Then a group of Arab astrologers is credited with constructing what they call as a thinking machine called the Zairja, which was designed. So, it was a collection of rotating discs with markings on them, and if you rotated the disc according to some input information, you would compute something. But their notion was to generate ideas by mechanical means with the help of a technique of breaking down called Al-Jabr, which, as some of you know, is a root for the word algebra. And by combining numbers, values associated with letters and categories, new paths of insight and thought could be created essentially. So, this fascination of autonomous entities, autonomous machines which are thinking machines, goes back a long time essentially. So, this Zerza caught the imagination of a Spanish Catalonian missionary called Ramon Lull, and who decided to design a Christian version of it, which he calls as Ars Magna. And he said the goal is to bring reason to bear on all subjects, and in this way arrive at the truth without the trouble of thinking or fact finding essentially. So, one thing, when you look at the quotations from these times, you must remember that some of the meanings of the words are a little bit different from what they are now essentially. For those of you who have read Shakespeare, for example, would know that Shakespeare's English is a little bit different from ours English, and our English, and we need to understand things essentially. But this notion of arriving at truth without the trouble of thinking or fact finding, of course, has been fulfilled now with programs like Google and so on. You just have to type in something and you get an answer essentially, right. So, by the middle of the 14th century, large clocks and figures became popular in many areas of Germany and Italy, and talking brass heads became closely associated with learned men again essentially. The Archbishop of Salzburg built a working model of a complete miniature town driven by water power essentially, operated by water power from a nearby stream essentially. So, one or two more examples. So, Vaucanson's duck. So, Vaucanson, so you keep note that years, this was he made this thing in around 1730 or something like that, which is quite long time ago. He was a French inventor. So, he is credited with having made an android which could serve dinner and clear tables for the visiting politicians. However, one government official declared that he thought Vaucanson's tendencies as profane and ordered his workshop to be destroyed essentially. We will see later that this kind of political oversight has influenced European thought quite a bit, political and religious oversight. So, for example, Copernicus and Galileo, and all these people were sort of worried about putting forward their ideas about what the world is really like. So, he created this, his most famous creation is this duck called the mechanical duck, which could appear to be drinking, eating, quacking, splashing about in water and digesting its food essentially, and became very famous 1739. And there is an image of the replica of this duck which is lying in some museum, somewhere. So, of course, in real life, meaning in the actual duck that he created, it did not have digestive abilities. The food was actually collected in the food that the duck was supposed to be eating was collected in one container, and the output was sort of pre-stored and sent out from another container. But he was hopeful that a truly digesting automaton could one day be designed essentially. So, there is fascination with machinery, is that is what we are trying to look at essentially. Another very famous example is this chess playing Turk by Kempelen, Wolfgang Kempelen, 1734-1804. He created a chess playing machine known as a mechanical Turk, constructed in 1770 to impress the Empress Maria Theresa of Australia, and the mechanism appeared to be able to play a strong game of chess against human opponents as well as perform the knight's tour. So, you must be familiar with the knight's tour. On a 64 board chess square, can you move a knight to cover all the squares exactly once, and the figure on the bottom is a knight's tour apparently created by the mechanical Turk. Looks quite a aesthetic figure to me. I think you might have written a program to create a knight's tour at some point. Now, this was a automaton which Kempelen took all over Europe. He impressed Napoleon and other people, beating his general at chess. And here is a picture of the automaton. you can see it essentially. Maybe I should have made it a bit larger. So if you look carefully, you can see that inside this box was a human chess player sitting there. So it was really a hoax essentially, but it was not discovered for a long time essentially, and it travelled for nearly 84 years, Europe and America, beating all kinds of luminaries at chess essentially. It seems Edgar Allan Poe wrote an essay trying to expose that this chess player cannot be a real machine. Okay, so let us move on to more useful things. Mechanical arithmetic. Can we make machines which will do arithmetic for us? So, Pascal of course, you are familiar with as students of science in various places. Pascal's name has appeared, not least as a programming language, name of a programming language. So, he invented a mechanical calculator using something called lantern gears, which we will not go into, and he tried out 50 different prototypes before presenting his machine in 1645 to the public. It was called Pascaline or arithmetic machine or Pascal's calculator, and it could add and subtract two numbers, that was its limits of its mental abilities, and multiply and divide by repetition essentially. There is a image of a Pascaline from one of the museums, and he received the rights to produce this machine and sell it in France, but it was not something which was commercially viable for him essentially. So, as this article says, the cost and complexity of producing the Pascaline was too much for him essentially, and production ceased in a year. But this is a real machine which could add, subtract and multiply two numbers. So, you can see we are already looking at the advent of calculating machines. So, all these are famous names, you must have encountered them. For example, Leibniz we know as an inventor of the calculus. So, these were sort of multifaceted people, they did all kinds of things in those days. So, he was a German philosopher and mathematician. He started to work on his own calculator after Pascal's death. So, he invented something which is called as a Leibniz wheel or a stepped drum, which could do counting in some sense. So, here is an image from the Wikipedia site. So, you can see there is a gear in the red color fixed to a rod, and depending upon, and there is a stepped set of teeth in the orange cylinder. So, depending upon where the gear is, it would be rotated some number of times dependent upon how many of those teeth it encountered essentially. So, if it was on the lower part, it would count 0 or 1. If it was raised to the extreme right, then it would be struck by, let us say 9 or 10 teeth, and it would count up 10. So, it is a small counting device that he invented. So, all these machines in those times were mechanical in nature. It is called the step drum, and as you can see from this quote, it was used for 3 centuries until the advent of the electronic calculator, which came only much later in life, in fact in the last century. And he built this machine called the stepped reckoner. So, the stepped reckoner, the stepped name comes from the kind of drum it uses, the stepped drum. It was a digital mechanical calculator invented by Leibniz around 1672 and completed in 1694. It could perform multiplication by repeated addition and division by repeated subtraction, and it could operate with 8 digit numbers. So, if you multiply two 8 digit numbers, it would give you a 16 digit answer. So, that was its precision, so to speak. Here is an image of the step reckoner from one of the museums essentially. Okay, so, Leibniz of course, was, as I said, a multifaceted person. He believed that much of human reasoning could be reduced to calculations of a sort. Okay, so, we are moving towards AI in some sense, that can we have machines, automaton which think and which can do reasoning, and including things like arithmetic. But he is going beyond arithmetic. He is saying that human reasoning could be reduced to calculations of a sort, and such calculations could resolve many differences of opinion essentially. So, here is a quote from Leibniz. He says the only way to rectify our reasonings, and mind this language is not modern language, it is a slightly old language. The only way to rectify our reasonings is to make them as tangible as those of the mathematicians, so that we can find our error at a glance. And when there is a dispute among persons, we can simply say, let us calculate without further ado to see who is right essentially. The motivation behind devising logic is the same essentially, and we will see that logic also evolved from similar background. But this idea that arguments can be settled by calculation, so you do not have to fight or something like that, also goes back to those times essentially. Of course, if you tell this to the UP government, they would not believe it. So, these are the general principles of his logic and in fact his whole philosophy, and they are that all our ideas are compounded from a very small number of simple ideas which form the alphabet of human thought essentially. Okay. So, it is a very significant step he is making essentially. He is saying that everything that we think about is essentially combinations of some small set of simple things. Remember, in those days physics or science had still not discovered the notion of an atom. All those ideas came much later essentially, and Leibniz is talking about the fact that there are small number of simple ideas which combine and form complex ideas to form new ideas essentially. And this is an idea which sort of carries forward to present day knowledge representation as well. There have been approaches to knowledge representation which says that we will work with a small number of primitive concepts and derive all other concepts from those concepts essentially. So, it is a very significant idea. So, the alphabet of human thought, and secondly, complex ideas proceed from these simple ideas by a uniform and symmetrical combination analogous to arithmetic multiplication. So, what he means by uniform and symmetric combination is that there is a well defined way of doing things essentially, the well defined mechanical way of, just like you have algorithms for adding or doing long division or multiplication, you have algorithms for combining smaller ideas into more complex ones essentially. So, there are two things he is saying. One is that everything, all ideas are made up of a finite set of simple ideas, and then there is a uniform way of combining ideas to form more complex ideas essentially. And remember, this was in the 17th century. The first commercial success of a mechanical calculator was in 1820. Thomas de Colmar from France, he built this machine and it was strong and sturdy enough to withstand daily use in the office environment essentially. So, if you look at the last paragraph, so these are some of the images which are of this real machines, and as you can see in the second paragraph, they were manufactured from 1851 to 1915. So, not even 100 years ago you might have found people using such a machine to do arithmetic essentially. The last paragraph says that its sturdy design made it a key player in the move from human computers to calculating machines that took place during the second half of the 19th century. So, I want to draw your attention to the phrase human computers. Before our computers, digital computers or mechanical computers that we will see in a moment were invented, the word computation was essentially applied to human beings. The human beings computed things and they were called computers essentially, and this is a term that we will see again later sometime. That brings us to the first computer. So, you are all familiar with Charles Babbage, I presume, 18th century. He was a mathematician, philosopher, inventor, mechanical engineer, best remembered for his idea of the programmable computer. All the machines that we have seen so far were not programmable. They could do arithmetic, for example, and that was about it essentially. Charles Babbage took this to the next step. So, he as a child was fascinated by the same automaton, the kind of talking heads, moving figures that we talked about, and this is a quote from what he said about some statues that he saw displayed by a man called Merlin, and he described them as saying they are these two feminine figures. He says one walked, used an eyeglass occasionally and bowed frequently, her motions were singularly graceful, and he says the other was a dancer full of imagination. I do not know how he got that, and irresistible essentially. So, this was a general fascination with talking, moving figures that was pushing all these ideas forward essentially. So, in 1822 he began building what is called as a difference engine. You must have heard the term. It was designed to compute polynomial functions more than addition and multiplication. The first engine was composed of 25,000 parts, weighed about 13,600 kilograms and was 8 feet tall. Here is an image of a difference engine. On the bottom you can see, on the bottom left you can see an image which is there in the London Science Museum, and on its right is a small enlargement of the gear systems that it was using, and on the top is a part of a difference engine assembled after his death by his son, using parts found in his lab essentially. So, that is the original Babbage engine, whereas what here is a recreation, modern recreation of the difference engine that you can see, but these are working machines. One place where Babbage got some ideas was from these so called Jacquard looms essentially. So, why is a computer a different machine from the rest of the machines? Because it is programmable. And how is it programmable? Because we have this idea of a stored program. We can plug in a program and run that program, then we can plug in a different program and run the different program. So, the stored program which can be input. The idea came from these Jacquard looms, which is a kind of punched cards that you see here on the left, which is an enlargement of the figure on the right, which were used to create designs in fabrics essentially. So, these looms were used to create these patterned fabrics, and the pattern could be controlled by these punched cards. So, this idea of punched cards is what Babbage took from there, and he created what is known as the analytic engine. It was a proposed, he did not actually build it, mechanical general purpose computer designed by Charles Babbage, first described in 1837. It had an arithmetic and logic unit, control flow, all modern terms in computer science in the form of conditional and branching loops and integrated memory, and it was the first machine which in the modern sense could be said to be Turing complete essentially, which means it is equivalent to a Turing machine. The first programmer was his accomplice or collaborator, Augusta Ada King. She was a daughter of Lord Byron, who was a poet. She is now known as Ada Lovelace, was an English mathematician and writer, chiefly known for the work that she did along with Babbage essentially. So, her notes include what can be called as the first algorithm, which is processed by a machine, and because of this she is often called as the first programmer, and the programming language Ada that you might have heard about, promoted by the US Department of Defense, is named after her essentially. So, she went beyond number crunching, again like Leibniz. She realized that the potential of the device extended far more beyond number crunching, and she wrote, and this is a quotation, that the analytic might act upon other things besides number, were objects found whose mutual fundamental relations could be expressed by those of the abstract signs of operations and so on. And then in particular she talks about generating music. She says that supposing that the fundamental relations of pitched sounds and the science of harmony and musical composition was susceptible of such expressions, the engine might compose elaborate and scientific pieces of music to any degree of complexity essentially. So, even then Babbage was just designing this analytic engine which was not even built, and she was imagining that such a machine could compose music essentially, because nowadays we know it can be done. And finally, in this study of mechanical history, we look at this first electronic machine which was built called the ENIAC. You must be familiar with it, but you can just see the size of ENIAC, 17,000 vacuum tubes, 7,200 crystal diodes and so on and so forth, 27 tons. It occupied a full room essentially. It was not even as powerful as a small computer that you have on a smartphone nowadays, but that was the first electronic machine essentially. So, with that we come to the end of the first part, which is the mechanical side of this thing. So, we will take a small break and come back with the second question, which is this notion of mind and philosophy. How did the notion of mind come back in philosophy? So, we will stop for a while and then we will start in about 3 or 4 minutes essentially.